Okay, the other part, my calculus doing friends, hello. The other part of 5.3 is determining what is it. Is it a disc, is it a washer, or is it a shell? And for a lot of people, that is the hardest part, is to get going on that. But that actually isn't that tricky. And it has everything to do with what axis that you're being rotated around and what your equations are solved in terms of. And so, for example, if your axis of rotation is the x-axis or something parallel to the x-axis, and your equations are solved for x, then these two come together and you should use the shell method. And on the other hand, if your axis of rotation is the y-axis or something parallel to the y-axis and your equations are solved for x, then you should use the disc or the washer method. If your axis of rotation is the x-axis and your equations are solved for y, then you should use the disc washer and the shell, right? So, and so it is pretty much that simple. And your equations, you can change sometimes what your equations are solved for, and other times you can't. So for example, if you have equation like this, y equals 2x, well, that equation solved for y, but it would be very easy to solve that equation for x. If I needed to solve it for x, I could. Whereas if I had y equals sine of x, well, it's not difficult to solve this equation for x, but then I get things I can't integrate because that would be x equals the arc sine of y. And I don't know how to do integrals with arc sine yet. And so that's going to be would be the problem then. And so if it's difficult, and then there's other things, so this makes it difficult. Difficult has an F in it. Really impossible. It would be awesome. Not just that, right? And this is okay. I could have either way. I could go either variable. If I have something like this, y equals x squared minus 3x cubed, you can't solve that for x. And so even if you have this, x squared minus 3x plus 1. I actually could solve this for x, and you actually did it in Math 1, but it makes something so gnarly. It makes square root in your answer and whatnot. It makes something so gnarly, so messy. You're going to have y underneath here and whatnot that you wouldn't be able to integrate with it, same as this. As I could do it. This I can't. Here I could, but then it's going to make it impossible to integrate. So when I say impossible, I mean impossible to integrate right now. Impossible to integrate right now, and makes the problem even harder. Okay, so you can sometimes arrange what your variable is solved for, but so anyway, so that's kind of that story. So we're going to try some here and see how we do. Get to doing problems, right? So here it says, find the, this is example 1. I think this problem probably comes out of your book. The way that I have it written there, I'm not sure if it does or not. I don't remember if it's the example 1 in your book, or if I just love this problem. I usually use this problem also with cosine. Love it, love it, love it for whatever reason, just because it gives me a little bit of practice at my U substitution. So it says to find the volume obtained by rotating the region about the y-axis, and so this is what they're rotating. Here is the y equals sine of 2x, and they said between 0 and the square root of pi over 2, and y is 0. Y equals 0 is the x-axis. And so this is what they're rotating about the x-axis. Okay, so that's what's being rotated about the x-axis. So if I decided that I wanted to use the disc washer, since I'm going around, did I say x-axis? I meant y-axis, right? Let me make sure. Does it say y-axis? Yeah, y-axis. if I wanted to use the dishwasher, then this would be dy. The same as what the axis you're rotating around. That's how I remember it. And that would mean that my equations to use the dishwasher would need to be solved for x. They need to look like x equals blah, blah, blah in terms of y. And I look up here and it's not. Well, would this be easy to solve for x? And the answer is no, it wouldn't. So the dishwasher method would not be good on this problem, whereas the shell method would be the other variable, dx, which would mean that your equations need to be solved for y, and I'm like, the other variable, right? Blah, 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 right? Y equals blah, 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 and that's what I have. And so I'm like, oh, perfect. It needs to be the shell method. So in order to use the shell method, you first have to come up with your h. So over here on my picture, you notice I haven't even drawn it in 3-dimension, and you certainly can draw it in 3-dimension. And if you want to see some really nice drawings, go check out Pat Serpa's class, because he draws these really well. Okay, H needs to be where your solid is, from the top of your solid to the bottom of your solid, parallel to the axis of rotation. So this right here is H. There it is, H. And something that goes from the x-axis to a point like this is called y. So this is called y. But remember, I wanted all my variables to be in terms of x. And look what y is equal to. It's equal to sine of 2x squared. Now sometimes I tell you that h is top curve minus bottom curve. The top curve is sine 2x squared, and the bottom curve is y equals 0. So it's sine 2x squared, right, top curve, minus bottom curve, minus 0. So I want to cross out the middleman. I don't want y there. I want this in terms of x. So h equals sine of 2x squared. I was being asked, what the heck does that mean? That's a height there. And so I want to get a scratch piece of paper and show you what that means to answer that question for my friends that were asking this question. I need my calculator too. Do I have a calculator? I do. Okay. So you agree that here is an h. This is where x equals 0. So we're going to find the h that goes with x equals 0. So that would be sine of 2 times x, so 0 squared, right? This is that. So this would be sine of 0, which is 0. So the height, this, at this point here, is 0. And so here, there's a h value. There's lots of h values. There's infinitely many h values, in fact. That h value is probably, because this is pi over 4, and of the blocks that you have there, this is pi over 8, right? Because it's halfway there. So if I wanted to find the height of this, okay, so when x is pi over 8, h equals sine of 2 times pi over 8 squared. So I'm going to put that in my calculator with my calculator on radians, right? So I didn't have to do the other one in my calculator because I knew the sign of 0. So here I am, sine of 2 times parentheses. I'm going to put my, just like I see it, pi over 8 in the parentheses here, square that, and outside there. I don't really have to have the times that I put there. There, I put a times in there, and I don't have to have it, or it's okay if I do. It's 0.3 to the 10th, and I just want you to notice this height right here, right? 0.1, 0.2, 0.3, 0.4, 0.5. So that's all that it is telling us. It's telling us what is the height for each given value of x of our shell, right? And so that's what it's giving us. And so here I could come up with what that is as an x value and figure out what the h value is that goes with it. So that's the reason we're saying h is this, okay? So now we have to find out what our radius is. Our radius. And our radius goes on a shell from the axis of rotation to the height. It's the distance here to here for every given height. And so for this particular height, the radius is whatever halfway in between those is and add it on it. But this one, I could talk about it more easily, right? This one right here, the radius is pi over 8 is what the radius is there. And the height we just found was 0.3. And they go together. So that's the radius of the shell. You can kind of, if you wanted to really get going on the 3-dimension, right? And so kind of here is my shell that I could pull out and cut it and then flip it open, right? So my radius, when it goes from the axis of rotation is the y-axis to a point, that distance is called x. Every single time from the y-axis to a point, that's called x. So this is x, and I wanted it in terms of x, so I'm like, hot diggity dog. So my volume is going to equal, on a shell, 2 pi times the integral of the, remember, it's the radius times the height, right? I already got the 2. It's 2 pi, the radius times the height, dx, right? That's the formula there for my volume. And I already got the 2 pi in the front. The r is x, and the height is sine of 2x squared dx. And my x's, and so this is going to pick up all of my heights that I could have. They start at 0, and they go right to here. And that value right there is the square root of pi over 2. So we're going to put that here, 0 to the square root of pi over 2. Okay, so there's our bounds there. And so we can solve this by a u substitution to find the antiderivative. What we want to let u is, so this is my plan, I want to let u equal to x squared. Then du will equal 4x dx. And that'll gobble up that x right there. So that du over 4x equals dx. So these are the things I'm going to plug in. Okay, and then my bounds are going to go, the low bound is x equals 0. When you put it in for u equals 2 times x squared. When you put in x is 0, we get 0. So coincidentally, the low bound is the same. But the up bound, up, we ran into a horse trainer. She was working in Yosemite, and she had all these mules. I guess those are not horses. And she was delivering supplies. So she had, she was riding a horse, and she had strings attaching the mules together, and she had 10 mules behind her, and all of the mules had packs on. And as that they were going along kind of a narrow path, I was surprised that they would be going like that, and the edge right there made me kind of nervous. She was yelling to the mules, up, 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 and I don't know what that meant to the mules. If that meant pay attention, you can fall over and then pull the rest of us over the edge because we're all attached together. I'm not sure, but anyway, when I think of Upbound, I don't know why that reminds me of that good memory. So here we have u equals 2 times, remember, x squared, but x was the square root of pi over 2. And when I square that, I get pi over 2. And then when I cancel out the 2's, I get pi. So my new bounds will go the low bound 0 to the up bound pi. And so that's pretty nice, right? Okay, so my volume then will be 2 pi. And my integral will be from 0 to pi, we said. And x sine of u And then dx is du over 4x. And see what's going to happen with the x. It's going to cancel, right? And that's good because I can take the integral of sine of u du, and the 4 is just a constant, so it can be put out in the front, so over 4 out here, and I can get rid of that too. And so that's the volume equals pi over 2 times the integral of the sine of u, but now that's an easy integral to find the integral of. That's negative cosine of u. And so from 0 to pi. So my volume of this crazy thing using the shell method will be pi over 2 times, and then this is going to be negative cosine of pi minus, right, minus, and then negative cosine of 0. You have to be careful about the cosine of 0 because sometimes people tell me, oh, the low bound's 0, so everything's going to go to 0. Well, not if it's cosine. It's not. The cosine of 0 is 1. And so this is negative of negative 1. So we're going to have here pi over 2 times 1, right? And then this double negative makes a positive, so that's plus. And then the cosine of 0 is 1. And so when it's all said and done, I think that this is going to be pi over 2 times 2, which is pi. So the volume is pi. So we did a lovely job on that one. So some of them you have the choice of doing, oh, I know where these examples came from. These problems came off my, the semester I put them on here, the previous semester, whenever that was, they had come off the test from the semester before that. And so I should have made a note to myself on that to remember. Okay, so that was that problem. Okay, so this problem, I called it example 2, and it's, oh, and I asked you to circle which method that you're using, and I didn't circle it, right? So I'm using the shell method, and so there I'm going to make sure that, and I crossed out, I'm not going to use that method. Okay. So this is the next example here, and so you want to make a basic sketch of it. And sometimes I make my basic sketch and then I realize it needs to be bigger, and I redraw it. So this is going to start here at 1, y equals the square root of x minus 1, and go this way. You could pick points if you needed to. So when I was first graphing things, I always picked points. So like if I pick 0 would not be appropriate because that's my favorite point to pick because square root of negative 1. So I'll pick 1. So that's the square root of 0, which is 0. I'll pick 2, which is 1, right? Because 2 minus 1 is 1. The square root of 1 is 1. I don't want to pick 3 because that'll be the square root of 2. Or 4 because that'd be the square root of 3. I want to pick 5 because that'll be the square root of 4, which is 2. And so I can then plot those points. So here's 1, 0, and then here would be 2, 1, right? And down here will be 5, 2 somewhere. And so you have to kind of know what it's going to look like. You have to know that it's going to be half a parabola, or you have to pick a lot of points, right? That's what a calculator does. Is it picks a lot of points. It can do it quickly. And then y equals 0 is is right here. And then x equals 5 is right here. All the way up, right? But where I'm looking at what area do I get bounded? Because I'm going to rotate that area and make volume, right? And so this is what is being bounded. And so this is my my solid there, okay? And so they said about the x-axis is what it says here. So about the x-axis. So if I was going to use the disc or the washer method, then this would be dx because I'm going around the x-axis. which would mean that my equations would be better if they were, need to be, not just better, need to be, equations need to look like y equals blah, blah, blah. And I'm like, hot diggity dog, that's what I got. So I'm probably going to use a disc or a washer. Whereas if I use the shell, it would always be the opposite. So if I'm going around the x-axis, it'll be dy. And that would mean that your equations need to be solved for x equals blah, 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 right? Which would mean that I could have to rearrange this equation and solve it for x, which is actually possible. And so I could use either method on this one because it's possible. So I think I'm going to use the shell, and then I probably won't be able to help myself but show you, I'm going to use the dishwasher, and then I probably won't be able to help myself but to show you the shell. It's very important when you take your test that you do tell me what method that you're going to use by circling the method that you're going to use. The reason is that sometimes I can't even follow what you got going on, and so I'm not sure, and I spend a lot of time trying to figure out, and so I don't want to do that. I want you to tell me what method you're trying to use, because people are like using half of one method and half of the other or something, and that's certainly not okay to do. Okay, so you start with the axis of rotation. Go put a dot anywhere on the axis of rotation, and that's where you're going to draw your typical radius. And because when I go through here, I'm immediately in solid, I'm not in air, I know that it's a disc. And so I'm going to have only one R when you have a disc. It's when you have a washer that you have the outer and the inner, right? And so I'm going to have only one R. And because I'm going from here to here, this distance, this is my R, and this distance is from the x-axis to the curve. Well, that distance is simply just called y. But I want everything in terms of x, and y equals the square root of x minus 1. So since I'm going around the x-axis, that distance right there is simply called y. But I want to get rid of the middleman, right? And I want to call that distance x minus 1. And we could do that same story that we had done on the other one to show the different radiuses that you would have. It's basically our table right here with the radius that would go, right? Okay, so when we set this up, our volume would equal pi, the integral of pi r squared dx, right? So our volume will equal pi, and then we're going to have our integral, and it's the square root of x minus 1, quantity squared, and so it's like hot diggity dog on that, right? And our integral is going to go from the very first r we would have. So all of these are infinitely many r's that I'm going to draw. I drew one typical one, but there are infinitely many of them, of the radiuses. And the very first one starts at x is 1, and the very last one is at x is 5. So 1 to 5 here. And now I'm in business. So here I'm going to get the integral 1 to 5 here of x minus 1 dx. So our volume is going to be x squared over 2 minus x. My mom is so bored that she's been watching my videos and sending me lovely comments about what I could do. And so big shout out to my mom. Thank you. I love you. And we're going to have here, that's boredom, right? If you're not in a calculus class and you're watching these videos. And so here, minus. So my volume is going to equal, let's see here, 25 divided by 2 minus 5 minus half, and then plus 1, right? I distributed the negative. I got 8, so this is 8 pi. Now, if I decide to do this problem using the shell method, I should get the same answer. And I do want to do that because I want to show you that you could do some problems using either method. And I'm digging in my recycle pile here for a paper that hasn't been written on. They're all getting really written on near the top. Okay, so I'm going to do this same problem, and so I'm going to make my basic sketch. 1 to 5. Okay. We're rotating around this axis. Okay. And if we decided that we were going to do a shell method, just for yucks, right? Just to give it a try, then your equations, this would be, remember it was dy, and your equations have to look like x equals blah blah. So we want to take that equation, y equals the square root of x minus 1, and we want to solve it for x. So we would square both sides, so this would be y squared equals x minus 1, and then add 1, y squared equals, y squared plus 1 equals x, right? So now I've got that equation, this equation right here, solve for x. Okay, so so we've done that. So now our next step is to identify what h is, and h is parallel to the axis of rotation. And so I'm going to draw my h in here. There is a typical h. And h is, if it's on its side, like we have on our side here, equation solve for x, it's right curve minus left curve is what it is. And you see that any h that I would draw would have this straight line as its right curve. That line is x equals 5. It's also solve for x, right? And so, and any h would have as its left curve y squared plus 1 as its second curve. So h is equal to 5. So this is right curve. Is this that bad pencil? And so h equals 5 minus y squared plus 1. This is where calculus students lose it, as they subtract a binomial and don't distribute the negative. So h equals 5 minus y squared minus 1. So h equals 5 take away 1 is 4. 4 minus y squared. In order to use the shell method, I need to know h and I need to know r. And so now I want to draw r. R goes from a typical h that you've drawn, and I've drawn several, so I'm going to erase out and have just one, to the axis of rotation. And that's what it is. It's the distance between h and the axis of rotation. And that distance, in this case, here, so, and I can draw it anywhere I want because it's the distance from h to here. So I can draw it in the middle, or I can draw it at a point right here. It does not matter. So wherever I draw it, do you agree that it's the same? So this is called R, and no matter where I draw it, because it goes between h and the axis of rotation, it's always the same for this particular value of h. Now if h is up here, right, then it's going to be a lot longer, r is. So r is not constant, it's just that it is no matter where you draw it there. So people were asking, does it matter? You always draw it at one of the ends, like this, to the point. Does it matter? And it doesn't. Now this goes from the x-axis to a point, and that's always called y. And so the distance from the x-axis to a point is always called y. And I want things in terms of y. So hot diggity dog, that's it. People ask me, is the radius always easy? Is it always, when you use the shell, is it always like y or y plus 1 or y minus 6 or something like that? And the answer is yes, it is. Okay, so now we're going to plug in our little formula for our volume, 2 pi RH dy, right? That's what we're going to have. So our volume is going to put the 2 pi in the front, and the r is y, and the h is 4 minus y squared dy. Excuse me, that's our h, right? And our bounds, they're not going to go from 0 to 5, friends, because those are bounds for x. We want to know, where do these h's go, right, that we had. So there was an h, here is an h, here is another h, and we want to know the h's in terms of y. So y is 0 here. That's my first h, right? And then these h's go all the way up to here, to this place right there. And what is the value of y there? Because that's the upper bound. Well, you might have to go back to your formula, right? Our formula, original formula, might be the most helpful. It was y equals the square root of x minus 1, right? And when they intersect here at 5, so if x is 5, what is the value for y? Yeah, y is the square root of 4, y is 2. So this height right there is at 2. So our bounds for y go from 0 to 2. So when we integrate this, we're expecting that we would get the same answer. In order to integrate this, we would have to multiply this together. So this is 4y minus y to the third dy. So this is 4y to the second over 2 minus y to the fourth over 4 from 0 to 2 times 2 pi. And let's see, when we put in 2, well, this can cancel, huh, and give me 2. So when I put in 2, that's 8. And then 4 squared, 2 squared, 2 raised to the fourth is 16. And 16 divided by 4 is 4. So this is minus 4 in there. And then minus 0. So when we plug in, we do get 0. I'm always careful about that because, you know, cosine is y. And so this is 4 times 2 pi. So our volume is 4 times 2, which is 8 pi. And that's exactly the same answer that we got when we did it the other way. That's not the same problem, though. There it is. See? Same answer. So you can see them both. And so both are good methods. You might say that on this one that the disc was easier on it, and the shell was maybe a little bit harder or whatever have you on it. There's times when one way is a tiny bit easier than the other way, and so it's experience that gets you to know which one. But we could have used either. So if this question had been on the test, there'll be people that will do it the disc method, and there'll be people that do it the shell method, and they're both going to get the same answer, and they're both going to be right. And so it's fine. You can do either way. Okay, so this is my third example, and like I said, where these problems come from, they came from the test. I'm going to have to shoot another video because I'm almost out of time on it. I think I'm going to get a little snack and then shoot the next video. Okay, bye-bye.